Recall from the beginning of this lesson that a basis is a generalization of the direction vectors for lines and planes. If a plane is through the origin, then every set of direction vectors is a basis for that plane, and every basis is a set of direction vectors. In particular, a plane needs two direction vectors. Three or more vectors is too many, and one or fewer vectors is too few. In particular, every basis of that plane has two elements. This generalizes to a theorem. Let S be a subspace of Rn. Any two bases for that subspace have the same number of vectors. This leads to the following definition. The number of vectors in a basis for a subspace S is called the dimension of S, and it's denoted dim S. For instance, the dimension of Rn is n because there are n vectors in the standard basis. If S is a line through the origin in R2, then the dimension of S is, now take a moment to think of it, it's going to be 1. And that's because there's only one direction vector for a line through the origin in R2. What about if it's a line through the origin in R3? Again, let me give you a moment to think about it. Yup, it is still 1, because a line, no matter what space it's in, has one direction vector and therefore one element in a basis. What about if S is the span of these three vectors that we've seen before? Well, if you remember, these two guys here form a basis for this span, and we've seen that already. And therefore, the dimension of this subspace S is 2.